Hello students, welcome ulit sa online tutorial natin. So, continue tayo, problem number 21. So, actually, I was already done with, not really done, no, but mga 90% ako sa recording na nag-shutdown yung PC, kaya I'm recording it again. But anyway, a T-beam section daw with BF, actually, the succeeding problems, mga 5 or 10 problems is about T-beams. So, the T-beam section daw with BF, may Excel file akong ginawa. So, you can actually access that one. I think nasa ito. So, the Excel file is available sa files tab, no, sa tutorial group natin. So, feel free to look at the Excel file. So, ito yung Excel file. Sandali. Yan. So, anyway, basically, no, you will just input the necessary input variables dito. So, by the way, this is only true for analysis, ha. So, hindi pa ako nakagawa ng Excel file, no, for design. But anyway, pag may free time ako, I'll actually create that one para ma-check nyo kung tama pa yung sagot niyo. So, anyway, let's try to answer this one using the Excel file now. So, based on the problem, we have PF na, anyway, lalagay ko na agad diretso, no. So, area of bars, ano ba yung area of bars? 528, so 528 mm diameter bars. FC prime is 21. Fy is 414. Depth of compression block, sinabi ba? Not depth, but compression depth of 560. And then beam width, ano yung beam width natin? Beam width, 500 pala. Hindi. 250 pala, sorry. 250, and then ang flange width is 500. And then diba? Meron tayong, this is actually case 2 daw. Anyway, check natin. Ano ba yung thickness of flange? 125. Yup, case 2. So, pag case 2, ano ba yung sagot natin dito? Ano ba yung tinanong sa problem? Ito pala. Yan. So, ang tanong sa problem is actually yung A at saka yung nominal moment capacity. Anyway, our answer is 160 and 559. Tama ba? 160 and 559. Yung A, ano ba yung A dito sa Excel file natin? A is 160, tama naman. While yung MN, MU is 559. Sandali, MU is 559. MN pala yung tinanong. Sorry, hindi dapat MU, no? So, MN kasi ang tinanong sa problem. So, dapat ang sagot is, burahin ko tong MV, ha? Yan. Ay, sorry. Yan. So, our answer should be, medyo lag. Yan. So, our answer should be 621, which is actually same lang yan. MN is 621 sa Excel file natin. Sige. So, again, feel free to use this Excel file. Ginawa ko to para mas maintindihan nyo yung flow ba, yung process. So, tingnan nyo, ang ginawa ko dito, I assume na nag-yield, tapos notice na, I assume na case 1, but anyway, mali pala, no? Hindi pala case 1 kasi greater than, kaya ag-solve ako ng bago. Okay. But anyway, ang sa atin lang, no, is makuha natin itong mga values na to. By the way, this Excel file is not yet completed, no, kasi if ever mag-yield, tama naman mag-yield, but if ever yung sagot natin ba, if ever yung still is hindi mag-yield, which is very seldom lang, ha, pag T-beams, very seldom lang. In fact, pwedeng hindi nyo na i-check kasi ang idea kasi pag T-beams, especially pag ang steel nasa ibaba, because of the very large concrete area, steel will always yield first instead of concrete crushing. Kasi nga, napakadaming concrete. Then, ang steel mag-yield. Maliban na lang kung medyo napakadami din ng steel na ilalagay dyan. Okay? But typically, steel will yield first because there is actually a very big area of concrete because of the flange, no, sa T-beam to consider. So, yan. So, anyway, I'll try to discuss the solution daw sa MathCAD natin. Sige. So, again, ang una nyong gagawin pag T-beam is always assume, no, na case 1. By the way, meron tayong dalawang cases, no? Meron tayong case wherein yung concrete compression block is less than T. Meron tayong case na ang concrete compression block is greater than T. Ang greater than T yung medyo mahirap, yung case 2. So, pag case 1, assume muna na case 1. Anyway, ang equation for case 1 is ito lang. C equals T, and then ang C is, yan. Ang C is 0.85, FC prime, AB, yan. And then ang T is ASFY. Again na, tingnan nyo, nag-assume ako dito na automatic Fy. All of the variables are given except for A, which is yung concrete compression block. After solving, we solve no that ang A is 142, which means mali yung assumption natin. Kasi I assume that A is less than T. Notice, T is 125, A is 142. Mali pala. Meaning, mali din yung A na nasolve natin. So we got the wrong A. However, we know that this is actually case 2. So we did this one to check if it is case 1 or case 2. But now that we know case 2, we need to use the actual equation for case 2 to solve for the concrete compression block, which is ang actual equation is ito. Now, I understand if iba din yung equation ninyo sa notes. If nakita niyo sa notes niyo, kay sir, di ba, T-beam niya dito is ganito. Again na, walang problema. It's okay if we have the different equations, but actually same lang yung lalabas. Okay? So, ang idea kasi, ang idea niyan is, paglalagpas kasi, diba, lalagpas man yan. So, paglalagpas yan, meron tayong area above, meron tayong area below. So, ang solution na to is actually, parang practical lang talaga, no? Area above, which is the area of the flange, and then area below. Sa akin lang kasi, I do not want to consider, or I do not want to introduce a new variable, baka medyo malito na kayo. So, ang ginawa ko, instead of dividing that one like that, so I actually use this division, no? Parang ganito. And then, by the way, it's up to you kung saan nyo gusto. Anyway, may advantage to, may advantage din yan. Ang maganda dyan, kasi yung equations yung medyo mas maliit manata. Yan. Okay, let's say this is the T-beam, and then ito yung compression block, diba? Ito yung A. Yan yung A. Okay? So, dito kasi, mapapansin nyo, ang A nyo dito is divided, kailangan nyo pang yan ang T plus Z, or meron pa kayong bagong variable which is Z. However, sa akin kasi, pag ganito, wala na akong bagong variable kasi I will divide this one like this. And then, I will consider this as area 1, and then ito, or yung kabila, siguro area 1, and then itong dalawa is area 2. Now, you might say, sir, di ba tatlo ang areas na yan? Yes, tatlo yung area, but you can actually merge the two areas, yung dalawa, kasi they have the same centroid. Ang idea kasi natin is, kaya we divided this one into composite areas of rectangle, kasi alam kasi natin yung centroid ng rectangle. Ang centroid kasi ng T, hindi natin alam. So, we cannot directly make the moment equation ba, yung mu d minus a over 2. So, since hindi natin alam yung centroid, mas maganda na i-divide natin to by parts, wherein alam natin ang centroid, which is, it's either ganyan or ganito. Anyway, don't worry, same pa din yung solution na makukuha nyo. Sige. So, anyway, since this is actually case 2 na, ito yung equation ko for case 2. So, sa case 2, ang C ko is now actually with two terms, no? Yung area. Instead, ang area is A times BF. The area will now be much complicated na. This is TF times BF. This is actually the area of the whole flange plus BW times A minus TF. Actually, itong A minus TF, this is actually Z. Now, sir, now you might be considering, sir, bakit ganyan? Akala ko ba, sir, na you use this area? I mean, yung area na yan. Bakit ang area mo is ganito? Actually, ito yung ginamit ko if the centroid is used. Kaso dito sa problem kasi, walang centroid din eh. Kailangan ba natin ng centroid dito? Wala kasi wala namang moment arm. So, instead since wala namang centroid, I just used the practical ng na division, yung same kay sir, no, na area sa flange plus BW times yung Z, which is in this case, ang Z is A minus TF. But don't worry, same kayo ng makukuha ang sagot. Tingnan nyo, meron nga akong pinakita, di ba? Ito yung division using kay sir, and then ito yung division using yung ginawa ko. Same pa din ang sagot. Okay? So anyway, para hindi kayo malito, tanggalin ko na lang to, ha? Yan. Sige. So anyway, by the way, for the whole equation, the only unknown is A. So you can use your calculator, shift solve, and solve for A. Anyway, I used my software to solve for A. I was able to solve 160.62 mm. So tama yung assumption natin, that is greater than 125. And then, tama din yung value ng A natin kasi we use the correct equation. So meaning, mali yung 142. Ang tamang A is 160. Anyway, after getting the correct answer for A, notice hindi agad ako nag-highlight kasi I need to check kung mag-yield ba talaga o hindi. But rest assured mag-yield yan. But anyway, just to check, solve natin yung C. C is simply equal to A over beta 1. Our beta 1 is still 0.85 kasi FC prime is 21 man. So after solving for C, you get the actual stress na 600 D minus C over C. You'll get 1,100, meaning lumagpas talaga. No? Lumagpas siya sa yield. So meaning nag-yield, meaning you can use yung A. Tama yung assumption natin dito. Kasi pag hindi yan nag-yield, let's say ang nakuha mong Fs dyan is 200, meaning you cannot use this equation. Palitan mo to, itong Fy, palitan mo yan ng 600 D minus C over C. But anyway, mag-yield man yan basta T-beams. So you have, tama. Next question, determine the nominal moment capacity of the T-beam. Again, ang nominal moment capacity is, wala kayong magagawa, no? You need to memorize this one. Okay? So that's 0.85, Fc prime TF, BF minus BW, D minus TF, and then this is BW, D minus A over 2. Ito, madali lang pag-memorize kasi this is just the same as singly reinforced, no? Ano? BW. Ito kasi, ito yung area, ito yung moment caused by the flange, you know, BF minus BW, and then ang moment arm niya is D minus TF over 2. So, our answer is 621. Sige. So, anyway, tama yung sagot natin. Although walang answer key, tama yung sagot kasi same tayo ng sagot sa Excel file. Sige, so same pa din. If you have any questions or clarifications, please do not hesitate to comment down below. Maraming salamat sa panonood and see you sa next video natin.